Welcome back. 9:45. NASA is on a mission to keep the world safe.
Later today, NASA's Double Asteroid Redirection Test, or DART, will intentionally crash into an asteroid nearing Earth in the name of planetary defense.
The question is, can we redirect an asteroid if we ever needed to? Here to tell us more about this exciting mission is a planetary astronomer, Andy Rivkin from Johns Hopkins University Applied Physics Laboratory in Laurel, Maryland. Good morning, Andy.
Good morning. Thanks for having me.
Hi, good morning. Well, first of all, this mission sounds like it could be right out of science fiction. Can you tell us what you are expecting to happen tonight?
Yeah, so the DART spacecraft will be coming in to meet Dimorphos, which is the moon of another asteroid named Didymos. It's coming in at 14,000 miles an hour, and it will impact Dimorphos at 7:14 Eastern time, so I suppose 6:14 Central time. And it will slightly change the orbit of Dimorphos around Didymos in a way that we're going to then measure from Earth.
Andy, the DART mission's about planetary defense. Talk to us a little bit more about that and what we're hoping to learn from this kind of test.
Absolutely. Asteroids have hit the Earth for billions of years. As long as there's been an Earth, asteroids have been hitting it. And asteroid impacts profoundly have affected the history of life on Earth. Unlike other natural disasters like hurricanes or tornadoes, asteroid impacts can be predicted ahead of time if we look, and they can be averted if we take action early enough and know about them. So unlike in movies where nuclear devices are kind of our only option, we are developing other options to avert an asteroid impact. DART is an example of one of those, where we take the spacecraft and change the orbit of what we're worried about by crashing into it.
And how will we find out what happens to Dimorphos after the collision of the DART spacecraft?
From the Earth, Didymos and Dimorphos appear as a single point of light because they're so small and so close together in the sky and they're so far away. From the point of view of Earth, Didymos and Dimorphos move kind of around each other, and Dimorphos moves in front of and then behind Didymos. And as that happens, the brightness of that point of light goes up and down. We've been making measurements like that for years. And starting tonight, we'll be making, or I guess we'll be continuing those measurements using telescopes on all 7 continents, seeing how the brightness changes now and comparing that to before the impact. And the differences we see will be due to what we've done.
Andy, I know you don't have a celestial crystal ball, but what is the likelihood of an asteroid being big enough to Earth that we would need to use this technology to avoid a huge natural disaster?
Asteroids the size of Dimorphos hit the Earth on average every kind of 20 to 25,000 years. So the odds that it's going to happen during our lifetimes is low. But we only know where about half of those objects are in space. So while on average we might be okay, we need to continue looking to make sure that we know where everything is out there. Until we can find everything out there and give ourselves the all clear, DART is just kind of an insurance policy to keep in case something is found that is coming our way.
Very good. Thank you so much, Andy, for joining us this morning. We appreciate it.
Thanks.
Andy Rivkin from Johns Hopkins University's laboratory in Laurel, Maryland. Thank you, Andy.